Alright, taking a look at number 63 on section 1-2. We're supposed to find the domain of this. First thing I'm going to do is look for any domain restrictions. And I've kind of got two things popping out at me. I've got a rational function sitting here overall. So I've got no zero is allowed on the bottom of a fraction. So I got to account for that. The other thing I have is I have a radical. And you know you can't take the square root of a negative number. So I have two domain restrictions to account for. So I'm going to go ahead and take care of the radical and the fact that it's in the radical is a denominator. I'm going to take care of that all at once. So y minus 10, because it's underneath of a square root, has to be greater than or equal to 0. But because that square root is on the bottom of a fraction, that means I also cannot have it equal to 0. So I got to get rid of that or equal to part. So it's just y minus 10 has to be greater than 0. So it was greater than or equal to because it was underneath a radical. It had to be positive. And then because it's on the bottom of a fraction, I can't have it be 0 either, so I have to get rid of the or equal to part. That's the confusing part about this problem. After that, it's the algebra of it is simple. I'm just going to take the 10 over, get y is greater than 10, and that is my domain. I just need to go ahead and I always like to graph it, take a look at it. I did have to adjust the window slightly. I think I took it up to 20 for the y's and over to 20 for the x's so I could actually see a little bit of the graph. But I mean, this explains the whole thing right there, though. I've actually got a vertical asymptote that's right at 10, and then all of my domain is from 10 and above. So my domain would be from 10 to infinity. I don't actually touch the 10, though, because I can't put 10 in here because it would make 0 on the bottom of a fraction. We can't have that. So I have to leave an open bracket. 10 to positive infinity is my domain.